Netflix presenter. He is amazing. He's the founder and CEO of Psykinetic, the organisation behind a mind-controlled wheelchair, virtual and augmented reality rehabilitation, and inclusive gaming that rely on eye movements. You may also know our speaker from your TV screens as the award-winning ABC documentary maker and presenter of Becoming Superhuman and Meet the Avatars. He's worked with National Geographic on China 2049 and presents 4 Discovery Channel documentaries, and has even started his own media company to create world-changing content on the intersection between technology and humanity. He has a list of awards and accomplishments far too long to read out, but I must mention this one. Our speaker had the very great honour of being MC for an amazing evening with President Barack Obama. TMC would like to thank our sponsor again of this session, Atura, for bringing this incredible person to our stage today to share his thoughts on the topic, Technology is Reinventing Humanity. Please give a very warm welcome to Dr. Jordan Nguyen. Welcome, Jordan.
Are we able to hear me all right? I feel like we might be.
Yes, I can hear you. You're live,
Great.
Jordan. Go ahead.
Excellent, excellent. Thank you so much for the introduction. I'm going to be taking you through a number of things today, which is all sort of future focused, looking at sort of the adventures I get to go on, the things I get to see around the world, and some of my own adventures in developing technology and the innovative process that we take. But a lot of it is focused on that idea of get out of university and where we're going with it all, and that ability to adapt to the changes coming our way. Really, we've heard quite a few things about the changes that we've experienced and what's sort of coming next and the kinds of technologies that we have available to us. So that's what I'll be going through in this talk. If you haven't seen me speak before, then I'm also going to just go through a little bit of the background first, and then we'll go into some of the latest things that I've seen around the world and why innovation is so rampant. Now, I always love this particular quote, which is "Intelligence is the ability to adapt to change," and it's by Professor Stephen Hawking. This is a quote that I think is it's just so true in today's day and age. It's something that is so true. Intelligence is the ability to adapt to change. We've seen that we are living at the fastest rate of change we've ever seen. You know, we feel this every day, but we might also be living at the slowest rate we'll ever see again. And that can be scary, but it can also be exciting. And so I think there's a lot to be excited by and to look towards the opportunities of where we're going with our advancements in science and technology and how they can impact the world. But I've always loved this quote. Now, I get to see a lot of things. As a TV presenter for ABC and Discovery Channel, I've gotten to see the world's fastest electric hypercar, lots of advancements in electronics, in technology, display technology, holographic tech, drones, not just drones you can fly really fast, but drones you can get inside. I'll show you that again in a little bit. I've also seen many things from manufacturing to genetics, genomics research, use cases of artificial intelligence, and a lot of those types of advancements around technology, how it shapes the world, the landscape, and our humanity. So that's the thing I've been really interested in. It's really that human connection element, you know, looking at how humans have come to thrive in different conditions, even in high altitude, in harsh environments, and how we're now really starting to harness a lot of the science and the technology and the advancements of our time to really create that next step. Now, we're fast moving into this space, this era called the Anthropocene, and that's where we, as humans, will create and architect those next steps in evolution for the world. And I think it's something that we're faced with. It's in our dialogue day to day, the impact that we have on the earth, and the sort of challenges that we face as a result. So the challenges are getting bigger. So this is why science and technology can also help us in this this manner. So looking at how we can also harness the technologies of today to build a better tomorrow, to build a better world, looking at natural ecology and how we can help out there. I was very lucky to do this this documentary with ABC last December called Reef Live, looking at the mass coral spawning events of the Great Barrier Reef. You know, this beautiful spectacle, this beautiful location that we have, and we're very lucky to have it. But what we got to do, I was hosting this with Hamish McDonald and Brooke Satchwell, and our friend Tim Flannery joined us on the show, as you heard from him yesterday. What an amazing guy, and it was so great to meet him in person and get to spend some time with him. Incredible insights into the way that we can take care of the environment of all sorts and wildlife on Earth. And this is what we were looking at. We were crossing over to the researchers who were doing all kinds of research on the reef, but looking at the impact that we've had on it, where it's going next, how we can preserve it, how we can harness science and technology to do things like restore it even into the future. So these are the sort of discussions and the sort of research and the sort of movements that are happening, and we need more of it. And so universities play a massive role in this. You know, the sort of research that comes out of universities are, you know, ever advancing. At the same time, we've got this amazing generation coming through, and I get to do a lot of talks. I get to do a lot of events with the young generations, the emerging generations, and they're wonderful. You know, they're just a whole different generation to anything that we've ever seen before. Having that connection across the globe, understanding what is happening in the world, and you know, feeling that level of, I guess, that level of weight on their shoulders, but also knowing that they want to make sure that they have a better future to live in. They have a future to live in, and a world to come back to. So really, the generations coming through, I'll go into it a bit more in a bit, but I'm seeing young people coming through where they're going to move towards those areas of impact where they will know that their life is going to matter. So they're taking on the types of career paths that are going to allow them to have that impact, whether it's social, environmental, being able to have a positive impact in the world. And that to me is inspiring as well. Very much looking forward to how we're going to guide this next generation coming through. I always say we should begin with inspiration and purpose. So I'll go through a little bit of my own background very quickly. My inspirations come from my parents. I always think we should harness inspiration to move towards where we want to go. My father is a professor in engineering. He became the dean of the Faculty of Engineering and IT at University of Technology, Sydney. He was working there from when it was the Institute of Technology, and the late 80s, early 90s, I always remember him bringing back all his different pieces of tech and the sort of ideas that he was always working on, and he still is. He still works in biomedical technology, moving from originally he was in power, then he went into to robotics, artificial intelligence, and later on into biomedical technology. So I followed in Dad's footsteps without really meaning to. I found my way over towards his side during university, but I was always on my mum's side through most of my upbringing and high school life, which was the artistic side. Mum's an artist. She's a very social, compassionate person, and and then at the same time, after my parents had me, 3.5 years later, they accidentally got triplets. They only wanted one more kid, but they accidentally got 3. And I ended up with 2 brothers and a sister. It was fantastic. We used to run around the neighborhood and set things on fire together. But we always came up with these imaginary environments that we went into. Something I found that was really interesting about when I was young as well was that my toys were slowly disappearing. I got to go into work with Dad one day and find out that he was working on robotics. Now, this robot is a big pillar. It had a claw in front of it, camera in the claw facing down, had a conveyor belt in front of it, and it would learn to pick up my toys and move them around. So it was learning through artificial intelligence. My dad could see that AI had a big future. Now, artificial intelligence as a term has been around since 1956. Had all these rises and falls over the decades, and this was during the second AI winter, as they called it, when it would fall. It was very hard to get research papers over the line and publications, but my dad could see it had a future. So I got to experience this and even play games like noughts and crosses, checkers, and chess against this robot. And it set in an early fascination for me in AI and robotics. I was thinking, I'd like to be able to work on that, but all through high school, I didn't think I was cut out for it. I was in the bottom half of my school going through. I got very lucky to get into my course, electrical engineering, which back at that point in time was only 72 UAI in 2002. And so I was very lucky. I got to get into to electrical engineering and start moving into robotics and AI. Started building robots that could take people on tours and started getting into it. But I didn't really find that level of connection with it. And I thought, this is a lot of fun, but I'm realizing that I want to be working with people. So I almost dropped out of uni, but my dad asked me to continue on, that he'd mentor me through the next semester. And it was in the next semester that I went to a friend's backyard pool party. We had a backyard pool and a diving board. One of my dives ended up going wrong. I went straight into the bottom of the pool and almost broke my neck. I got put flat on my back, day and a half, couldn't move, couldn't roll over. And it made me think very differently about life, all the things that I've taken for granted. And that pushed me over into the space of learning about disability. Now, I found out in Australia at that point in time, I found out that 1 in 5 Australians have some form of a disability, and 1 in 16 Australians have severe or profound disability. And I couldn't believe that statistic. I thought, where is everyone? 1 in 16. So I started going into high care homes, into hospitals, into charity service groups, and I started looking into how could a person utilize any sort of technology to regain that sort of independence if they've acquired an injury, or how do they utilize tech day to day. And this is where I started realizing the biomedical space was a really interesting space to move into. So I was able to steer my my university degree towards biomedical. Started learning about how the body works, learning about some cool things like the electrical systems of the body, the fact that we move our hands, our brain sends electrical signals to every strand of muscle fiber within a muscle, and that's what makes it contract. We've got the electrical signals of the heart, the electrical signals of the eyes, and the brain. And so I was harnessing the electrical signals of the brain, because what I wanted to do was to build a wheelchair for some of my mates to be able to control the wheelchair using their mind. And single project based on inspiration, working with friends of mine and the people who are inspiring me, I quickly realized it was possible to control a wheelchair with the power of the mind. And so I kept iterating on it, working with people very closely, having a lot of different connections with industry as well, going out into hospitals and learning different insights, and then going and testing with them as well. And so in 2011, I ended up completing trials after failing my first set of trials very quickly. It wasn't working, realized it needed to be a lot more intuitive. And I ended up completing trials with 20 people. This is a mate of mine, Albert, who he broke his neck in a motorbike accident 5 years before this. He's controlling the wheelchair with the power of the mind. The headband is picking up on the little electrical signals of the brain called electroencephalography. No surgery needed. And it sends the signals into the computer. The computer runs AI in the form of machine learning. So machine learning is the main type of artificial intelligence you hear about. It's the one used in pretty much everything. So machine learning is very, very good at finding patterning. It was a custom neural network type of machine learning that was learning the patterns of his brainwaves when he was thinking thoughts that it's seen before. So he was able to associate a thought with right, with forward, with left, and then the wheelchair itself is a robot. So it can see and think and avoid all the objects and the people, so you can't crash it. That was the idea. It's called shared control, where the person and the robot are sharing operation over the control. Now, I wanted to see how much further this could go, and really, this was a big, big turning point. Now, I found that through university, it set me up with this ability to not only design technology, but really understand myself and believe in myself. And I think that's what I really gained out of university. I was there for 10 years, 5.5 years undergrad and 4 years PhD. And at the same time, during the PhD, I got to travel and go and present at conferences in other countries, got to meet a lot of people, and even eventually become a public speaker and TV presenter. Now, I'm terrible at public speaking. I was bad even for an engineer at that point in time. I had a lot of trouble presenting any of my projects during class, and this was something that I just learnt those skills of. In the last panel session, we heard about the importance of social connection, incredibly important. That social connection, that face-to-face connection, as good as virtual systems can be, it can't be replicated, because we have amazing things that happen when we're in the presence of other people, including the physiological effect on our brains. So I'll come back to all of that. But getting involved in the social life, I was involved in the engineering society. I was running that for a while. I was running some bar activities like trivia, and that helped with that social connection, that social ability to then go on to becoming a speaker and a communicator as well of the sort of work that I do. But the connections that I formed at university, I also kept, and the industry connections also built on those. So I ended up working on setting up my own social business called Psykinetic. Psyche and kinetic, it's putting the mind into action. And that was to make sure that we could do a lot more with this type of tech, to look at what else is around the world. And this is what innovation is all about. We use the building blocks of what has already been created out there. We put them together to create new solutions, new ideas. And this is involving an eye tracker connected to a tablet PC. This little girl jumps every time she crashes it. So she was steering that spaceship with her eyes. Katia is 3 years old, high-level cerebral palsy. To put this into perspective, one child every 15 hours in Australia is born with CP, and often the parents don't even know what it is. Very blanket term, but it tends to involve the movements of the body being affected. So during the birth process, there might be damage to the motor cortex and the basal ganglia, so that lot of movements can affect speech as well. So Katia might never be able to walk or speak, but harnessing this type of technology, eye trackers that are used in many applications like research and gaming, it detects where your eyes are looking at on the screen. So we started building games, cognitive assessments, music, communication, wheelchair control, all kinds of things, utilizing these technologies that are off the shelf. They're out there, easier to build and faster development times. What we started realizing very quickly through all of these endeavors is that anything is possible. In today's day and age, you've got these amazing tools out there. So really it comes back to our inspiration, the purpose we set out for ourselves. How are we going to take these tools into the future, and what sort of solutions are we going to come up with? And this is what I always tell students that they need to be focusing on. Find what inspires you, because if you know what inspires you, you've got a million tools out there, all these amazing things that you can learn. You can create any solution that you set your mind to. What we've realized is anything is possible. I'm going to take you very quickly through this story before we move on to some of the other things I've seen out in the world. And this story is called Becoming Superhuman. It was my first ABC documentary. I got to work with my young friend Riley. Riley was 13 years old at this point in time. He was born with high-level cerebral palsy. It affects all of his movements and his ability to speak. So he connects with the world through his eyes. He would look around. He can communicate through his eyes with his parents. His parents are able to detect some of the movements. He utilizes technology where he can type on a screen with a keyboard. We ended up building for him a much faster eye tracking device, which we've been testing with him ever since. And in this documentary, what I wanted to do was to achieve a big dream. You know, to come up with a big idea, a big dream is a cool thing. And if you're able to communicate that to people, people jump on board with big vision and big dream. And this was what we wanted to do. His dream was to drive a car. So we got a cool team together, you know, all uni students, interns. I built this team very quickly, and people got on board and just helped us out with piecing together this idea of Riley driving a vehicle. We found an off-road buggy from our friend in Perth, who sent the buggy over to us, and we started connecting it with all of this equipment. The idea here was that we wanted to rapidly prototype a system so he could drive the car with his eyes. Now, because he connects to the world through his eyes, we thought we'll harness that. The headband that he's wearing picks up on the little electrical signals of his eye movements. Whenever you move your eyes, your brain sends electrical signals to the muscles that push and pull them. So that's what we're harnessing here. The electrical signals of the eyes go into the computer. The computer runs machine learning, which learns to detect the differences in those patterns depending on which direction you're looking in. And then we set it up so that we could drive the vehicle with Riley in control, using just his eyes as a control mechanism. He can also feel the environment through vibrations in his arms like a superpower. But when Riley took off in this obstacle course we set up, first thing he did was crash. Then he brought it back to the start. He let me know he was going to keep going until he got all the way through the obstacle course in a single run from start to end, and he would not give up until he got there. This is an incredible thing. We saw him go through the course 25 times. I'm going to show you the final run because it's an amazing thing. Check this out. Good to go. 3, 2, 1. Cut. Take it easy. Take it easy. Forward. Forward. Take it easy. Take it easy. Nice. 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 Keep it straight. Keep it straight. Keep it straight. Right. Yeah! We did it! Up, up, up. Oh, buddy! Oh my God! You drove a car. Oh my God! Oh, we got there. I hope you were able to hear that all right. I could see there was a little bit of feedback going through, but that was the idea of becoming superhuman. We wanted to achieve Riley's dream. He pushed his own limits. He crashed 25 times trying to get there, and eventually made it all the way through to the end. It was the most incredible experience. We started to realize really quickly that anything is possible. Now, I wanted to find out what else is happening in the world and how many other innovations are out there that we can start to harness. And I started realizing it's absolutely thriving all around. So in my Discovery Channel documentaries, these have taken me all around the world to many different locations. So I'm just going to go through a few of the top picks of some of the amazing technologies that I've seen in the world. Now, we've got the flying vehicles. I mean, they don't look quite the way that they did in the movies, but that's okay. So these are passenger carrying mega drones. So they're electric and autonomous. You've got four arms with blades above and below. So there's actually 8 blades, 8 batteries, and 8 IMUs. IMUs are the inertial measurement units, the things that you find in your phone that can help track its angle and movement. And so these are an ability to not only lift and fly the vehicle, but it's also got many levels of redundancy in case a battery explodes. So one of the tests, only about a week before I got in it, saw a battery catch fire. 3 of the blades go out, and then the vehicle still safely landed. The founder told me this just before I got in the vehicle for my test, but it was pretty cool. So the idea is this goes straight up through the cloud, straight to the location that you're aiming to go to, and straight down. You don't have any controls in front of you. Completely electric, completely autonomous, flying cars. This is something I saw a little while back. It's a 3D printed house. I thought this was impossible, but an incredible thing. So this is not what I was expecting to see when I heard I was going to see a 3D printed house. I was expecting to see something that looked like a messed up cake, layer by layer, as you tend to get in additive manufacturing of 3D printing. But this is the idea of scale. You take a 3D printer, you make it really, really big, and then it can print concrete. Layer by layer, going up the walls. They're able to build this particular mansion. It's absolutely massive, start to end in 10 days for about $70,000. They were able to do a 1-story house in 4 days, start to end, for about $10,000. Unbelievable stuff. I saw all kinds of energy generation technologies a little bit more recently. So it was end of 2019 and very start of 2020, I was able to go and see the types of energy generation technologies around the world. One of those is called a molten salt power station. Unbelievable tech. It's really cool. Harnesses the heat from the sun. So kind of like if you've got a magnifying glass and you harness the sun's energy and you focus those rays and the heat, obviously you can set things on fire doing that. This is a very similar sort of thing. Instead, you've got these gigantic mirrors that all beam the sun's energy to the top of a tower, and it looks like a space city. So it beams the heat to the top of the tower, gets up to about 565 degrees Celsius at the top of the tower, pushes molten salt through it. So the salt stays in this molten state, which is kind of like lava, and it moves through all of these different vats. So when it's kept hot, it stays in the molten state. They push it through tubes that basically pipes that boil water. The steam turns turbines. The steam can be condensed back into water. So it's all very renewable as well. So it's really only using the heat from the sun, which is incredible. This was 4 kilometers end to end. So they've got one of these in Nevada, one in China, and we almost ended up with one in Australia, the largest one, but that one didn't quite pull through. We were going to get a 150 megawatt power station in South Australia, but I think the funding fell through. I also saw some other cool technologies like new advancements in hydrogen fusion technology from the big international collaboration, ITER, looking into how these countries have come together to realize the idea of hydrogen fusion. They think they're about 15 years away from basically the holy grail of endless clean energy. Could be a possibility, but it all comes out of big insights, big ideas, and big research. So this is also another collaboration I got to see, which was the widest angle telescope in the world, where they get given different targets to look at into the galaxy to image many different types of information. Now, unlike a normal sort of the optical telescope that you're used to seeing, this just picks up on a lot of the spectral data. It's got a moving piece, which is the one here. It's a big moving mirror. It goes up to another mirror, beams it back into the sensor. The sensor can take 4,000 stars, images or collect the data from 4,000 stars in a single sitting, in a single image, which is pretty cool. So what they're doing here is they're gathering a lot of data about the galaxy. Now, this widest angle telescope in the world it's actually been used to find many cool things. One of those was they recently discovered stars so far from the center of our galaxy that they realized the Milky Way galaxy that we are within is actually twice the size previously thought just 5 years ago, which is not a small difference. They used to think it was 50,000 light years from the center to the edge. They discovered stars as far as 100,000 light years from the center, which basically means that the Milky Way galaxy is twice the size that we previously thought. It in 2014 also discovered something called a hypervelocity star. Stars that can travel so fast they can escape the gravitational pull of an entire galaxy. So incredible things. We're learning more about the universe outside the Earth as well. And in getting to go there and see the technology and to do a story on it overnight was incredible. Now, back to Earth, what other things are happening here? We're looking into how we can improve our technologies and do things like even improve a staple food source like rice. Now, there's a lot of work being done in genetics and genomics research as well, again, coming out of many levels of university research. The discovery of CRISPR-Cas9 was made in 2012. It won a Nobel Prize in Chemistry just last year. And looking at how CRISPR-Cas9, which is a method that basically it's utilizing a method to as molecular scissors that can basically cut DNA, silence certain genes in DNA sequences of various crops or even humans. I mean, there are trials being done on trying to make humans more cancer resistant and the likes. But what I was getting to see was how the future of crops might be more weather resistant for the staple foods like rice. Now, if you look at rice, it needs a lot of water to grow. So to do things like utilize CRISPR-Cas9 to potentially silence certain genes that could make it more disease resistant and potentially utilize a lot less water, this was the idea of this research. Now, I got to see this at the beginning of last year, looking at how rice could potentially grow yield in drought conditions because many areas of the world are starting to experience those effects from climate change. So what I was seeing here was high yield rice growing out of basically dust. I was able to pick up the dirt underneath it and it would just go to dust. It was drought conditions. High yield rice was being grown out of it, many different variants based on the CRISPR-Cas9 technology. Then at the beginning of last year, right before, at the end of January, I actually had gone through Asia and ended up on the border of China and Russia in this massive national park, looking at how one of the largest cats in the world, the Amur tiger, and also the Amur leopard, how these animals were now being protected in this conservation effort, which, it shouldn't have gotten as drastic as it did, but it was lucky that the governments came together to work on this idea with Intel, with WWF International, to bring together this protection through this national park. But they also set up cameras. Now, these cameras utilize cloud services, so they send information over the cloud. There's a lot of machine learning that's been done to recognize what different animals look like. So it triggers the camera trap. It triggers the recording for 10 seconds anytime it sees an animal go past. It'll automatically catalog it in the cloud. It can also recognize individual tigers by their stripes and individual leopards by their spots. So the more the researchers could understand the movements of these apex predators as well as their prey, the better they could help protect them. And so the reduction in poaching as well was a big thing, because poachers are detected very quickly. And so it was an incredible effort that's been happening over the last 10 years. They've seen a massive rise in the numbers. And so it's something that's working, in one of the most inspiring use cases of artificial intelligence that I've seen. Now, we're quickly moving into this era of the imagination, and I think this is an exciting thing to recognize. We are living in this era of the imagination where anything is possible. So really it comes down to how we choose to harness our science and our technology. We've seen that virtual worlds are on the rise. The metaverse is on the rise. From virtual reality to mixed reality to augmented reality, we're seeing incredible advancements in these types of technologies. We were looking at this quite a few years back, and I was saying well before the pandemic that we have the ability to go virtual with our technology today if we wanted to. We'll find entire businesses would be able to run from home. You could do online learning and not have to ever go into a classroom. But I always said that I don't recommend it unless it's absolutely necessary for whatever reason. I wouldn't recommend it full time. It has its advantages, but people need people connection. We thrive on human connection. A big thing that's come out of neuroscience research by some of my friends in Adelaide more recently is looking into how when we look into each other's eyes, our brains produce new neurons specifically for the other person, particularly when it's the first time you've met, and particularly if you get along. So we physiologically change each other in each other's presence, and I think that's a beautiful thing. But it's looking at how we have that effect on each other, and how important human-to-human face connection is very important. Now, looking into virtual reality and how these might change over time, how we might find other opportunities, I did this documentary called Meet the Avatars with ABC to look into what sort of effects virtual reality is having in augmented reality, how our interactions might change, how our research might change. Now, we're learning a lot of things about the brain and body, which is awesome. This research came out of Brazil. So originally done in Brazil, virtual reality was being utilized in rehabilitation of spinal cord injuries. Now, you may have seen the research where people are walking on a treadmill each day with an exoskeleton. People have had acquired spinal cord injuries, and there was no particular rise in the level of rehabilitation, but it's good to keep the muscles working anyway. But then they introduced virtual reality into the therapy, and all 8 participants in this particular study, what they would do is they would look down and they'd see their legs on grass. They would see that they were independently moving their own body. Now, this research was incredible because what it did was it opened up this whole new door to this whole other area. Every one of those 8 people started moving and feeling it again after about half a year. The technology and the research made its way to Australia, and I was lucky enough to see this. My friend Angus here, he was utilizing VR in his therapy after a complete C7 spinal cord injury. He was hit by a car while cycling one day and completely severed his spine at C7. Now, complete severing of the spine, what are we told about that? No signal will get down or back up again. He was told, don't even try to feel your feet again because it's not going to happen. You know, don't live with that hope. So he was told that very early on. But he got involved in this new type of research, which was very exploratory. He tries virtual reality each day in his therapy. Instead of seeing functional electrical stimulation to his legs and a therapist moving his legs for him, instead he sees that he's independently climbing Mount Everest or doing something independent where he looks down, his body he's in control of his body. An incredible thing started happening. After 6 months, he started moving and feeling again. And just a few months later, he wanted to show us this. This is an assisted stand. He wasn't able to do it the first day, the only day that we had for filming. So I came back at the end of filming, we brought the crew and we got to see this thing happen, which made it a little bit more real for me too, because this is like watching a miracle. Here's Angus attempting to do an assisted stand after about 7 to 8 months of therapy utilizing virtual reality from a complete spinal cord injury. I'll move this on. Just like the phone.
No. Okay. Okay. Just, can you get me back? Yeah. Let's see, come forward on that chair. Yeah. I'll show you guys on that. Okay, so come in really tight. I'm ready.
While the electrical stimulation straightens his legs, actually getting upright is all down to Angus.
Come on, Angus. Hang on. Okay, two hips. Oh, smooth. Keep it up, huh? Yep, hips forward.
Just unbelievable. To see that was like watching a miracle. And so this type of research is advancing. We're seeing virtual reality being opened up into many areas of health and medical. And then we move further along the line. So virtual reality, you go completely into the virtual world. You're not seeing everything around you. Augmented reality is where we bring digital assets into the real world. So these headsets are going to get cheaper. Right now, they're still very expensive. This is the HoloLens 2, still about $5,000. But like most pieces of tech, they get smaller, cheaper, lighter, faster over time. And so eventually we're going to get glasses, maybe even contact lenses where we can interact with digital tech, with even, you know, the apps on our phone, instead all around us in holographic form. This is the sort of thing that, you know, has a lot of use cases in the classroom of the future. You know, being able to interact with the becomes very multimodal, and you learn in an entirely different way. And I was told this from a 10-year-old about 5 years ago, when she let me know that her generation are very multimodal. They want to interact with the content. That's how they learn best, and it's because that's what's available to them. You know, they've got these connections with all these kinds of technologies. So this is a cool insight. The fact that we can bring up holographic representations of the content that we're teaching, and our students can all see it and interact with it at the same time. So from virtual reality to augmented reality, these types of technologies are just going to keep advancing and going to have many, many use cases in the future beyond what I've shown you. Now, the students, the emerging generations, I get to do a lot of cool things like run competitions with them. So I've got this one competition, Little Big Idea, that I run each year from years 4 to years 8, and they come up with ideas, they send them in, they keep their ideas. We hope to see them utilize the funds to take their ideas a lot further. I was sending the winners to NASA before, now they're getting $10,000 grants, also great, to take their ideas further. And honestly, that ability to, well, I guess the opportunity to come up with ideas, to be innovative, to look at the world around you and look at the challenges and the problems that you'd like to see solved and come up with those solutions is a great opportunity. It's something that I didn't do enough of when I was young. found it a lot more later on. But this is the sort of thing that we're fostering, because the kids of today are going to be the change makers of tomorrow. And I keep consistently seeing this. Amazing ideas coming through, and that sort of unbound imagination as well. We all remember what it was like as kids, you know, that limitless imagination. Some of the best ideas we actually see coming from the younger grades. And one of the strange trends, well, maybe it's not that strange, but we did start to see this, is that the year 3 and 4 category and the year 5 and 6 group both tend to come up with more creative solutions and more wild things that you'd think, is that possible? Those are the kind of ideas that tend to come through. But years 7 and 8, suddenly there's a bit of a drop in how wild the ideas are and, you know, how imaginative they are. Instead, they start to become a little bit more practical. They tend to send in ideas that you know instantly can be made, but don't really sort of make you stop and think about the potential of it. An example, one of the finalists for this year's competition, we haven't gotten to the winners yet, but one of the finalists came up with this idea for, instead of using street lamps, could we utilize bioluminescence, inject them into trees and have glowing trees? And initially we just went, it doesn't sound like it would be very efficient. But then we started looking into his idea, and he had fleshed out this idea quite a fair way. And those ideas that make you really think, you know, is this a positive thing? Will this actually work? We love that. You know, it's a different way of thinking, but it's about the human. It's not about the technology. You know, what we're saying with kids coming through is they want to know that their life is going to matter. They're going to have that social environmental connection. They want to utilize the technologies that they've grown up with as well. So really the classrooms of the future are going to utilize all of these pieces of technology. There's going to be some amazing new developments as well. And some of those are coming from the areas of not only artificial intelligence, but graphics work and a lot of the movies and gaming industries combined. So this is, again, part of Meet the Avatars. This is what I started looking at in terms of avatar technology. How can we build avatars that may find a way to, I guess, transcend death? The idea here was I would have loved to have met my grandfather. He passed away just before I was 2. If I had an interactive version of him, I would love that, to be able to talk to him, ask questions, hear his voice, see his manners and gestures, and get to know him for him. I would really love that. So final story I'll go into is that of Maureen and Miguel. It's in the documentary Meet the Avatars if you'd like to watch it. But we took 2D video, made a 3-dimensional version of Miguel, working with some researchers from Newcastle Uni, and then we built this avatar to for Maureen to meet. Miguel is fit and healthy. He's well. He's in the room, but you're about to see virtual Miguel. The idea that he could be around for future generations to talk to. Check this out.
Now, after 50 years marriage, she's about to meet her husband for the first time in virtual reality.
Close your eyes. Keep them closed.
Having had a look myself, I can't wait. It's time for the avatar to meet the family.
When you're ready, open your eyes.
Oh my goodness. Hello.
Hello, ciao. Ci vediamo.
To meet the family.
When you're ready.
Castelnuovo, does that ring a bell to you?
It's a little village on the Adriatic side of Italy, on the south.
Have you got anything that you would like to say to me?
What I like about Maureen, a big smile, and she's a really good wife.
That's beautiful.
You know, I don't think I could have done any better with her.
Few challenges with the video then, but it looked like it was coming through. Look, an amazing thing to get to work on, and a beautiful couple to get to work with as well on this this technology. Now, this is the sort of thing that we're seeing. You know, it's being able to utilize these technologies for good, for looking at how they may potentially have an impact in our future. And I'm just going to try and bring up the slides again. And this idea that we can harness these technologies to build a better tomorrow, it really comes down to us and to the students that we're helping guide through these next steps. So we've got to help students find what inspires them, and we've got to adapt with purpose, and we've got to allow the students to adapt to the changes coming their way as well. Empathy, inclusion, social connection and collaboration is so important, it's so key in this whole journey. It's all about the human, not about the technology. So it's never about the tech, it's all about what we can do with it, how the human experience is going to adapt and change over time. And remember to dream big, because we are only limited by our own imagination. A lot of these technologies and a lot of the topics here, I go much deeper into many of these different tools, the technologies that we have today in my book, A Human's Guide to the Future, if you're interested in that. Otherwise, I think we've got a few minutes for some Q&A, but thank you so much for having me. Cheers.
Jordan, I'm still crying after watching that video of the avatar. That is just extraordinary. I just don't know that there will be a dry eye in the house, so I just need to catch my breath after that. Amazing work, Jordan. You are living a real life. If anybody knows the Netflix program, I think it's on Netflix, Black Mirror, or it was on Netflix, you are living the real life Black Mirror existence. Absolutely incredible. But with all of the
positives.
Yeah, well, that's right. It's a positive version of Black Mirror with integrity and with optimism. We've got so many questions and only a few minutes left. The first question I'll just jump to, Jordan, is can you hint at any projects that you're currently working on? I mean, my mind is already blown, so I don't know if you can even go beyond what you've already told us, but can you hint at any projects you're currently working on that will wow us in the future, in the next few years?
So I'm looking currently at a few cool things. So one of those is my new production house I've put together. Yes, that's a DeLorean, because very on theme. So with the production house, and it's also my own personal lab, I'm able to set up a lot more of my own ideas. And so here's a real brief look at one of the next technologies that I'm working on, which is future of robotics. This is a robot called Tio that I'm building. He's going to be 1.8 meters tall. And I've currently got the face working and a few other little bits of the intelligence and the tech there, which is looking at the future of social robotics. I want to be able to explore where are the positives, obviously where are the ethical issues. Every advancement, as you mentioned, Black Mirror, every advancement brings about new ethical issues and new challenges for us to solve, new dark sides, but there's always positive opportunities in there. And it came up in the last panel as well. It can be difficult to sometimes see those positive opportunities and where we can go, particularly when we're feeling the effects of the pandemic and lockdowns and the likes. But we've always got to keep it reimagining where that future is going, what the future could look like, not just the future depictions that have been given to us from science fiction, which are often dystopic, but instead rewriting that future to be a positive one, one where we do harness these tools to create a better world and where we collectively move towards that. We all have a part to play, and I think that itself is an exciting narrative to know that we individually have an effect on the world around us, the people around us every single day. So let's make that a better world that we're moving into.
And in terms of that part to play and making it a better world, I mean, we met Professor Tim Flannery yesterday. You've worked with him, spent time with him. He is just so wonderful. In terms of technology meeting our environmental climate change goals, how do you think that is going to play out?
Well, it's a very big question, and it's a very important one. These tools that we have at our disposal now, like that, these tools that we can harness, they are becoming more powerful, and it means that we can understand more things about the environment. That's why I loved seeing AI utilized in animal conservation and seeing it actually working too, seeing the effects of that. And the same thing goes for natural ecology, looking at the environment and how we can learn more about it. AI isn't just like a silver bullet that, you know, it's not just going to work for everything. But what it can do is it can give us incredible insights. And one of the best ways that this is starting to happen is in the idea of digital twin technology. I call it virtual twins because we're not going to have digital for that much longer. But anyway, whole different story. So we've got virtual twins or digital twins. And what this is you give insights, you give data from the real world into your digital version, and that could be a person, a robot, a place, it could be an entire planet. Now, if you take part of the natural ecology, if you take an area of the environment and send information, send data to the digital twin, you can get simulations, AI to play it like a video game, gain insights into that as to how you should, say, deploy resources like fire is in a bushfire. And you can gain insights into what worked in the digital world in that simulation. So you feed in data, you get insights back. These are one of the many ways that we can harness the technologies of today. Really, it comes down to our imagination, how we're harnessing these incredible tools that we have, and the sort of movements that we want to make into the future, for the future of our environment, life on Earth, and the planet as a whole. So really, these come down to us.
It does. Super quick last question,
Yes.
Jordan. In terms of universities and the knowledge base that you've actually been able to access through your tertiary studies, and then becoming a public speaker and presenter, documentary maker, filmmaker, how did you tap into the resources at university to sort of bring you from being, I guess, a timid presenter or one that you said wasn't very good at speaking or public speaking to somebody who's just so proficient and amazing at communicating with others now?
That's right.
And a second part to that question is, it's one thing to be brilliant at what you do in the field that you've chosen to work in, but it's another thing to be able to communicate that to others. So tell us a little bit about how you access that.
Absolutely. I started saying yes to more things. So I went through that stage at sort of towards the end of my undergraduate degree of starting to say yes to things, getting involved in the social life, which I wasn't really that heavily involved in to begin with. The first half of the degree, I sort of stuck to myself, tried to study, didn't do particularly well. I was on a pass average. Then I started getting involved in the social life, meeting people, doing a lot more of the sporting events, just getting involved in getting to know people. And those conversations I found started making me smarter. It's just, I understood the things I was learning more, because we would come up with sometimes seemingly silly ideas, but we'd talk about how we could make them together. And I'd be working with, sitting down at the bar with different friends, scientists, the accountants and legal people would join us as well. And what we'd do is we'd look at these different ridiculous ideas. Sometimes they're absolutely silly, but from different perspectives.
Jordan, super quick, because we've got literally 20 seconds.
Okay, and just being able to have those conversations, get involved in more things, really did set me up. I had the opportunity to speak for high school students too while at uni. And so really I just followed the pathway that I loved. And that's what I would say. Allow your students to find what they love and move in those directions.
Jordan, you are amazing. Jordan Nguyen.
Thank you so much.
I could talk to you all day. I'm so sorry that we have to leave it there. There were so many questions, both from our delegates and just from myself personally. Thank you again for joining us. I'm going to say goodbye to you now.
Wonderful. Thank you so much for having me, everyone.
Thank you. Now, a big thanks again to Jordan Nguyen for joining us. How incredible is he? Now, beginning shortly, we have concurrent sessions 7, 8 and 9, and another 9 presentations for you to enjoy over the next hour. All these presentations are from our contributing authors, and we thank them for their efforts. Please make sure you engage with them through the discussion board and the live Q&A. The chairs in each session will facilitate Q&A at the conclusion of their talks. Coming up, the Melbourne Connect series, Navigating Change in Unprecedented Times. Another topic to watch for, the pandemic and learning spaces of the future. Make sure you tune in. Don't forget to post on the event live stream. Fill in the survey and ask questions to earn points and grab the chance to win some great prizes. Remember to check out the virtual exhibition and information that's been provided by our sponsors and exhibitors. Thanks again to our major sponsor, Turner & Towers, and exhibitors Atura, Arm Architecture, Grosvenor Engineering Group, Ambius, Capital Insight, GJK Facility Services, Integrated Facility Management, Planon, Smarter City Solutions, and our conference hosts, ATEM and TEFMA. Enjoy the sessions.